Hey, Desmond Du here from NoSleepCreative. Today we will learn how to build a radial delay rig to offset a layer's property and time using expressions. This is more of a case study, and we'll be focusing on how to use a couple of expressions and doing a series of exercises to understand how this concept works. Even so, we will take a look at the reference scene for the animation in real time and slower playback speed. As you can see, each tile is appearing in a radial staggered fashion. The bottom square scales from 0 to 100, with the spheres appearing and floating up with a color change. Each tile is actually a single precomp with the time remap value offset based on the distance between itself and a control now layer. And that's how you get this radial delay animation. It might seem complicated, but this radial delay setup is a very common expression technique that we can easily build. And with that, let's get on with the tutorial. Alright, so this radial delay rig works by using expression, length, linear, and valueAtTime. We simply figure out the distance between a layer to a control now layer and use it to calculate the animation delay. To demonstrate how this concept works, I have a series of text layers arranged in a grid, and in the source text value, I wrote an expression that measures the distance between itself to this now layer over here. So notice how the number changes. When I move this now layer, is measuring distance based on pixel. So if I were to move it to the top left hand corner, you can see now the value has changed to about 42 pixels, and then at the bottom right it's about 1900 pixels. So also to help visualize the distance better, I have a square grid underneath the text layer. So the further away they are from the now layer, the lower the opacity. So notice as I drag this now layer to another corner, right? It's kind of bright where the now layer is, and it's dark where at the top right hand corner of this grid. Using this distance data, we can determine how many seconds to offset the animation using the linear function. So over here, I have a similar setup, but instead of the position, I have the numbers are how much each layer is being offset. So if I were to drag this layer around, so right now, my now layer is in the bottom right. So if I were to, first of all, let's get rid of the keyframe position I have here so we can see clearer. So as I move this around in the top left-hand corner, right, the offset is about 0.01 second. And then if I were to look at the bottom right, it will be not close to 1 second. So that, and then I can move this around, right? So the closer they are to this now control layer, the shorter the delay will be, and the further away they are, the higher the delay. To put this concept into practice, let's first learn about the length function. So in this composition, I have two balls, right? And if I was to move them around, I wrote an expression onto a text layer over here that calculates the distance between these two layers, right? So to do this, we can do this ourselves using a text layer, or you don't have to. We're just doing it so because everyone can see it clearly. So I'm going to open up the source text position, and we are also going to open up the position of our two circle layer. Right? Option click on the stopwatch. Let's create a variable called d, and then the length function, right? To measure distance, we use the length function. We just need to type in length parentheses and then pick width to point number 1, which is our target layer, which is one of the circle, and then point number 2, and then after that we can just click outside. So right now we're getting a long list of number because there is decimal. So what we can do is just type in math.round parentheses d, right? And this should round it up to 390. So when I move and this layers around, you can see it's updating accordingly to this text readout I had in the beginning, right? So that's the length function. It's something very simple to understand. Next, we need to understand how the linear function works. The linear function takes in 5 values, the input value low and high, and the output low and high. You want to think of the value low and high as one range, right? And this is range number 2 for the output low and high. What this means, what this expression does is that it basically remaps the input value range to the output value range based on our input value. So over here, I've written the expression linear time 06 2080 onto the opacity property of this circle over here. And I have a readout of our time and opacity of the circle. So when I play the timeline, notice, as time is increasing, so is the opacity, right? So it's just remapping the value of, so when time, our input value time goes from 0 to 6 seconds, increase opacity to 80. To better visualize or understand how linear interpolation work, I have this timeline that I made in the composition over here. So same again, it's the same setup. I have this linear expression onto the opacity of the circle, and over here we can see how the values are being remapped. So as time goes from 0 to 6 seconds, notice how the opacity is changing. I'm just gonna play it, and you can see that is clamped within this range of 20 and 80, basically the output value range that we insert. So like I said, you want to think of it as remapping one set of value to another. And that's how the linear interpolation works. And of course, the input value doesn't have to be time. For in this instance, this example, we're going to use distance instead. We're going to create a variable called distance and use the length function and put it in here. So we will start, we have a quick demo over here, right? So I have two circles, and I wrote an expression into the opacity of this, the blue circle. So when it's closer to the red circles, the opacity will be full, and then if it's further away, opacity will be 100. And also have a readout of the information on top, right? We can measure the distance and the opacity. So I'm going to get rid of the expression over here, and then after that, we're going to redo it, write it ourselves. So let's go into the position. Let's open up the position of our target, which is the red circle, and our own position, the blue circle. Option click on the opacity, and let's create a variable, d. So let's type in length, parentheses, right? Let's measure the position of itself, and then comma, position of the target, semicolon. And then after that, we're going to type in linear, parentheses, d, 0. So right, this is the minimum distance, and the maximum distance, this composition is about 1080. So let's put that. And then when distance is 0, the opacity should be 100, comma. And then when it's further away, the opacity should be 0. And let's plug that in and see if it works. So, right, if I'm further away, the opacity has become darker. And yeah, that's how you use the linear function in this instance. So let's get to the fun part where we actually put this into a real world scenario, into an actual radio delay rig over here. So this is what we're going to create. It's using the same concept, but we're going to offset the scale and opacity animation that's coming from the now layer over here. And notice when I move this now layer, right? The staggering animation, it will be affecting from the middle, right? So let me play this. You can see that animation is, like I said, from the middle. And if I shift it to the top right hand corner, the animation now is coming from the top right hand corner. So this is a very simple setup to create. So over here I have a composition which you can practice. I remove all the expressions, so you can just start here. It's called exercise 01. And the first thing we want to do is to, let's see, create a now object that will be our target to measure. So let's hit Command Option Y, and I'm going to type in Control. And then let's go into open up the position. So in this example, I'm going to use add in slider controls we're going to break apart the distance and the offset values into slider controls so we can see things better. You don't have to do it. You can actually write everything in just one into the scale or the opacity property. I just want to show you guys how things can be broken apart. So let's add in slider control to our sprite, and let's call this one distance, and let's Command D, and the second one we call offset. So you know the drill. Option click on the stopwatch, length, parentheses, pick whip the position, comma, pick whip the position of the control, and close it. And now for the offset, option click on the stopwatch. We can create a variable called D, and then let's grab the slider we created, and we can type in linear, parentheses, D. So when distance is 0 and the max distance, so this composition is about 1920. So let's round it up to 2000 for the max distance. So when distance is 0, right, the delay should be 0, and the max delay, when it's further away, should be about 1 second. So D02001. Okay, so that's the time to offset. And now I can copy these two sliders over here, and let's Command A to select every layer, and deselect the first two layer, and just paste all the sliders over. So you can see we have the slider now. And let's animate the position. No, let's animate the scale of our control, the S and T, the scale and opacity. So let's put a keyframe down, and let's set the scale, move the scale, 100 keyframe to about 20 frames, and set a 0 keyframe. And then let's increase opacity at 100 to at 20 frames. Now let's go to our sprite layer, right? And grab opacity and scale. So option click on the scale and pick whip it to the control scale property and type in dot value at time. So by itself, it's not going to do anything. But if you were to write in time, right? Basically, it's sampling the values of the scale property at whatever time that we have here. So I mean, whatever value we put here. So over here, we put time. So we can easily change this to, let's just say 0.5, right? And it'll be a static value. You see, if I move it around, nothing changed. If I go to half a second, so which is about 15 frames. At 15 frames, you can notice the scale is 75%, and the scale is also 75%. So it's sampling the value at a certain time. So we can, using this concept, we can grab our offset, right? We grab our offset, let's create a variable called offset, and then pick with it to our slider control, semicolon. And then we can use this, type in time minus offset. So it's sampling the scale animation, but it's pushing it back. It's delaying when it starts the animation. So you can see it's already working. Let's copy this expression. Option click on opacity stopwatch and paste it in. And instead of scale, let's use opacity. And now we can select these two properties, Command C and Command A to select everything and paste it on to the rest of the layers. And now, if I were to play it now, we have our radial delay rig. As you can see, it's not very difficult, right? I can move this around, and then it will still work. And if you want the delay to be slower, back in the linear interpolation, you can write instead of 1, you can write maybe 2. But we're gonna create in our next setup, we will create a slider control to control the max delay, right? And so now we get to the last part of this tutorial, which is to actually make the preview animation that I had at the start. It's using the same concept, and in this composition called exercise 03, I have everything set up for you. So I have everything is tile. I remove all the expression, and this animation, each tile is actually coming from this one set of animation that I made over here, right? It's just a simple the square appearing and then a sphere floating up. All right. So this time we're gonna use the same concept of like the distance using linear function and the length, but we're gonna write it into time remap property for the layer. So again, let's create a now layer, Command Option Y, right? And let's put it on top. Let's call this controls, and we are going to create a slider control, and let's call this max delay. So this will be the max delay of the staggered animation. Let's keep it at 2 seconds, and let's open up the position. So instead of breaking the expression into different parts into slider controls, we're going to write it directly into the time remapping property. So let's right click on the layer and go to time, enable time remapping, and then let's option click on the stopwatch. So we can type in D is equals to length, right? Parentheses, and let's grab the position of our controls, and then comma, our own position. And then after that, let's also type in semicolon. Let's grab our max delay variable, create a variable called max delay. And let's grab, let me just retype that. Max delay is equals to, and let's grab our slider control from the now layer. So let me just shift this to the right hand side so you guys can see clearer. So let's pick whip this to the control and then semicolon. And then we're going to create a new variable called offset is equals to linear d variable, and then at 0, and then the max distance, let's put it at 2000, and then 0, right? Since at 0 distance, there shouldn't be any delay, and then the max delay, which currently is 2 seconds. And finally, we can add in time minus offset. All right? And we can copy this expression, Command C, and select everything else, and Command V to paste it on. And we can play it, and oops, let me play it all the way. As you can see, our animation is appearing, in a radio delay fashion, right? So very simple. And just to kind of finish up this animation, and by adding more details, what we're gonna do is to have it kind of push out as it's like appearing. And we can do so by parenting all the child layer, or this tile layers, to the control now, and then writing an expression into the scale property to not inherit scale and animate the control scale. But here's what happens when I select all the layers and I pick with it and parent it to control, right? Suddenly, everything is not working accordingly. Well, this is because if you open up the position property, when we parent all the layers to control, we actually convert the layer space into that, and it becomes relative to the now layers, into the parent space, right? So if I were to undo this, you notice how the position value changes, even though they're still in the same place, right? So I'm going to undo it. The position is the same. The position changes, value changes, but they still stay affixed. So to troubleshoot this problem, we have to make a modification to how we measure the distance of the between itself to the control layer. Instead of using the transform position, we need to convert the anchor point of both layers into world space and then measure that instead. So to do so, let's grab the anchor point, right, of our control layer and our tile layer. So first, let's get rid of this variable called d, and we're gonna rewrite it, but let's create a variable called tgt target, and let's reference the control layer, right? So we do so we don't have to write a longer code. And to measure the distance, we're gonna type in again d length is equals to. So first of all, we need to convert this layer to world space, so to world, and then the property we're converting is transform dot anchor point, and then comma, and we are going to grab the target layer and then convert it to world space parentheses and grab its own anchor point. So tgt dot transform anchor point. That's why I create a variable called tgt, so we don't have to have a long string of line of code. And then if I were to close this, it should work. And I'm going to copy this, Command C, and select everything and paste it in. And now if I were to play my animation over here, right, you see everything is working accordingly. And even if you were to unparent it, it will still work. So for simpler setups where you're not parenting, right, you don't have to write that longer piece of code, but it's just good to keep in mind how to troubleshoot this problem. All right, so let's keep moving forward. Now that we parented to the now object, we don't want to inherit the scale. Notice when I change the scale, right, of the control, everything changes. I want to stay affixed. So we can write an expression into the scale property, and you can use this expression on screen I have over here. So I'm going to option click on the scale and paste it in. So what this expression does is basically do not inherit any scale change, right? It does not inherit any scale change from the parent layer. And I can copy this scale property and paste it onto the rest. So now when I set a keyframe, actually if I were to change the scale, notice it's like pushing inwards, but it's still maintaining its scale. I can push it outwards if the scale is bigger. So I'm going to set a keyframe here at 100. And then at about 5 seconds, let's set a keyframe down for 80. And select both keyframe. Right click, keyframe assistant, easy. And let's play that. And yeah, that's how you build this radio delay rig and the preview animation. Like I said, you can download the project file and try it out yourself. I also included my preview animation project file so you can reference my process. All the expressions I use are also in my wiki cookbook page. All the links are in the description below. And we're done! Thank you for watching this video. Please like, share, subscribe so this video can get to more people. I hope you love this master study. As always, if you made something with this tutorial, please tag me on Instagram at @DDesmondDo because I love to see what you made on your own. Alright, that's all I have for you guys. I'll see you next time.